All right, welcome to the second day of 1.6. We're just going to do a couple warm-up problems, about 3 of them. So you can only see 2. The next one's on the next slide. And then we're going to do a little bit of notes. But before we get there, let's roll with the math humor. What keeps a square from moving?
Square roots.
That's good. All right, you guys. Let's start. I want you to do numbers 1 and 2. So you're going to pause, work on 1 and 2, and then you're going to come back and we're going to go through the answers together. All right, you guys, the first one says, which of these ordered pairs is on the graph? Remember, in order to see if it's on the graph, your coordinates x and y both have to go in and satisfy the equation. So when you went through A, B, C, and D, if you plugged in -6, 0, so -6 here and 0 here, what happens is you don't end up equaling 12. So that doesn't work. You go through and you try each one, and when you get to D, 4, 0, well, 3 times 4 minus 2 times 0. 3 times 4 is 12, minus 0. That does give you 12, hence the reason why D works. In number 2, they want you to find the center of the circle. Well, they give you the endpoints of the diameter. So they give you, sorry guys, they give you that the endpoints are at 2, 5 and -2, 5. This is the diameter, so it cuts straight through the center. If I want to find the center, it's really finding the midpoint or the middle point. So you have to add your x's, divide by 2, add your y's, divide by 2, and when you do that, your answer is D. Last one. Jill drew a circle in the coordinate plane, and then she drew the diameter. What's the length of the diameter? Now, in order to do this, to find length in a coordinate plane, you have to use the distance formula. So go ahead, pause, come back, and we'll see if we end up with the same answer. All right, you guys. You should have labeled your points x1, y1, x2, y2. Plugged it in. You should have gotten the square root of 80, and when you take the square root of 80, you get about 9. Round to the nearest unit, it said, so we have about 9 units.
So for our notes in this section, we're going to start off by talking about a theorem. A theorem is just a statement that has to be proven before it is accepted as true. So we're going to deal a lot with theorems. The very first theorem we're going to talk about here, however, is the Pythagorean theorem. So you've actually dealt with this in algebra a little bit, and the Pythagorean theorem, developed by Pythagoras himself, is stating that, number one, it has to be in a right triangle. You're working with a right triangle. And if you're working with a right triangle, it says that the sum of the squares of the measures of the legs is equal to the square of the measure of the hypotenuse. So if we're working on a right triangle, what does that mean? In my right triangle, you have 2 legs, and you have a hypotenuse. And what you're going to do is you're going to take both of the legs, square them, and add them, and that should equal the hypotenuse squared. You've also seen it something like this with an A, a B, and a C. You might see it as an A squared plus B squared equals C squared. So what we need to do in the first example here is we need to find out what x is. And if we're going to find out what x is, first thing I notice is that x is sitting on this side of the triangle, and I'm dealing with a right triangle. So it's across from the right angle. So if it's across from the right angle, this is my hypotenuse. It's the leg, or I shouldn't say leg, it's the side of the triangle across from the right angle. So what I like to do when I'm setting things up like this is I like to circle my hypotenuse because that's the one that has to be by itself in the Pythagorean theorem. So setting up the Pythagorean theorem, we're going to take both of the legs, square them, and add them. So we're going to do 5 squared plus 12 squared equals the hypotenuse squared. Then all we have to do is solve it from here. So I get 25 plus 144 equals x squared, and then we get 169 equals x squared. So if you're square rooting then to solve for your x, you get x is 13. Remember, when you square it, you should get a plus or minus. However, it does not make any sense for us to have a -13. So that's the first example. Why don't you go ahead, try out the next example with the Pythagorean theorem, come back, and hopefully we'll have the same answer. So in the second example, taking a look at this one, we ended up having 10 was our hypotenuse, and we were solving for this x. So we start off with x squared plus 8 squared equals 10 squared, which is slightly different than what we did before. But that hypotenuse always has to be by itself, so make sure you're not just putting an x on that side. It has to be the hypotenuse. So if we set this up, I'm going to end up getting x squared plus 64 equals 100. Subtract. I end up getting x squared equals 36. Square root it, and we get 6. Now, does that make sense for both of these answers that we've gotten? Make sure you check it out. If I put a 6 down here, now my drawing's off, I apologize. But does it make sense that my legs should be smaller than my hypotenuse? Absolutely. Just like with number 1, if we take a look at the legs should always be smaller than the hypotenuse we got, and that was 13. So number 3, if we take a look at number 3, it says, what is the diagonal measurement of the television screen shown below? So what we're trying to do is we're trying to figure out what is this measurement here. So I know that the length of my television is 40 and the width of my television is 30. So I want to find out what the hypotenuse is. So let's go ahead and use the Pythagorean theorem and solve that. Do that for me. Pause. And when you're set, go ahead and start it up again. So by setting up my Pythagorean theorem, my legs were 30 and 40, and I needed to find out the hypotenuse. So we did 30 squared plus 40 squared equals x squared, solved it out, and we ended up getting x was 50, meaning that the diagonal measurement of my television screen is 50 units, inches normally. So keep this in mind when you're shopping for a television. If you're shopping for a television, they normally... oh, like always, duh, sell the televisions by their diagonal distances. So if you're looking at a 60-inch screen TV, send it to my house. But other than that, it's talking about the diagonal distance. All right, make sure you do your whisk, and we'll see you tomorrow.